Hello, welcome to part 2, mining our blockchain, and congratulations again for developing correctly with me part 1 to turn this previous general purpose blockchain into a cryptocurrency. So now we're going to do the required modifications in part 2, mining our blockchain, and of course these required modifications will have to do with the transactions. So we will need to integrate the transactions somewhere here in this part 2. I guess you know where exactly we're going to add them. But not only about the transactions, it's still the same two pillars as what we had to develop for part 1. Well, we'll need to take care of the nodes, of course. We'll need to add some nodes, even if the nodes are more related to part 3, decentralizing our blockchain, we will still create one address for a node here, and then at the very end of this implementation, we'll create some other addresses for other nodes. But the main work in this part 2 will be about the transactions. We will need to do two things. First, we will have to integrate the transactions, of course, in this response here, because we now have a new key when a block is mined, which is of course the key for the transactions that contains all the transactions that were accumulated in our list of transactions just before they're added to the block. And then of course what we'll have to do, and that's at the heart of a cryptocurrency, we'll make a request to add a new transaction to the blockchain. And this is when we will, for the first time, make not a GET request, but a POST request, because we will create this transaction into a JSON file in the JSON format, and then we'll post this JSON file containing the transaction into the response, which will also tell us which block the transaction was added to. So that will be the last step of this part 2 development. We will do that actually in the next tutorial, but today we're going to take care of our first node's address, and then we'll turn this mine block method into the right one for us to be able to mine a block that this time will have to include some transactions. So let's do this, and let's start with our node's address. So just between creating a web app and creating a blockchain, we're going to add here first a comment saying what we do, and which is simply we are creating an address for the node on port. Well, you know, the port right here is 5000. So remember, we have a different port for each node, and since we're starting here with the port 5000, well, this node right here and the node we are integrating this whole blockchain on will be the node on port 5000. But then, no worries, we will create some other nodes, but that will have different ports. But here, let's start with port 5000. And so, how can we create this address for the node on port 5000? Well, first, we'll introduce a new variable, which will be node address, and that will contain the address of this node. So now the question is, and actually the questions are, first, why do we need to create such an address? And second, how are we going to create that address? So first, the answer to the first question, why do we need to create that address? Well, that's because whenever a miner mines a new block, well, he actually gets some cryptos. That's exactly what happens for Bitcoins, for example. Whenever a Bitcoin miner mines a new block, he or she gets some Bitcoins. And therefore, there is a transaction from the node on which the miner is to this miner getting the Bitcoins. And that is why it is fundamental to get an address for this node. It's because whenever we mine a new block here, for not the Bitcoin but the Hatcoin, well, there is going to be a transaction from this node address to yourself. All right? So that's a first type of transactions. And then, of course, we'll have the general transactions from, for example, Adelin to Kirill. And that's exactly what we'll do, by the way, in the demo. I'll be sending some Atcoins to Kirill. But the first type of transactions is not to forget. Whenever a miner mines a new block, he gets some Atcoins, and therefore there is a transaction from the node to the miner. All right, and then of course the second reason why we have to create this node address is that, remember in this add node method, well, this method takes the address of the node as argument. And then, you know, we parse the URL and we take the netlock, which is this part of the URL exactly, And then using the request, we can catch the right node using that address, that netlock, to get the proper response. So that's another reason, but the first reason, more based on the theory, is also fundamental. All right, so let's create that address. And that leads us to the second question. How exactly are we going to create that address? Well, remember, we imported the UUID4 function from the UUID library. And this is exactly how we'll create that address. This UUID4 function will generate a random address, a unique address, and this address will be the address of our node. So for you to visualize this more clearly, you know what this UUID4 function will return exactly? Well, let me walk you through Google. Here is Google, and we'll do a quick search on this UUID4 function. So here, I'm going to type UUID4. Well, we can add some parentheses. Yeah, Python, however you want. And perfect. The first link is the Python documentation. That's exactly what we want. Here you have a lot of explanations on what is UUID, you know, the library, and then the function. I think we have some explanation specifically on the function. Here it is. UUID4, generate a random UUID, and a UUID is this kind of format, you know, a unique address for anything, and in our particular situation, a node. All right, so this is what we'll get, but you'll see that we will want to remove the dashes for our node addresses, so we will delete them, and the trick to delete them, you'll see, will be to replace them by nothing, and to do that, we'll use the replace function right after we create this address. But anyway, let's do this right now. It's going to be quite easy. So let's go back to Python and let's scroll down, and here it is, node address. And to create our node address, well, we'll first take the str string function, because we'll need to make that address a string. So that's the first step. Then that's when we'll need our UUID4 function, which, as we just saw in the doc, will generate a random but unique address for our node. But then, as I said at the end, we want to remove all the dashes, and the trick to do that is to replace them. You know, we want to replace the dashes that we have to put in quotes by nothing, which will basically remove them. All right? And that creates our node address, our first node address. Congratulations. This will be the address of the node on port 5000. All right, and now let's move on to the next step. So the next step is actually to fix this MineBlock request linked to the MineBlock function to, again, turn our blockchain into a cryptocurrency. And you know, of course, what we have to do. We need to include the transactions. And so now I'd like you to pause the video and try to do the exercise of implementing the required modifications to be able to mine some blocks that receive transactions now. And now I'm going to provide the solution. So we have actually two modifications to make. I'll start with the easiest one. The easiest one is, of course, to add the key corresponding to the transactions. So I'll add this key. We add a comma here, and then the key that we have to put in quotes, because we have to include the name of the key first and then the value corresponding to that key. So the name of this key will be very simply transactions. We can have several of them. That's why I'm taking this plural. So transactions, then colon here. And then to get these transactions, we'll take our block, because remember that we created a block here using our createBlock function, taking as argument the proof that we solved here using the proof-of-work function and the previous hash, that is the hash of the previous block. So that gives us a block which we take here to get our transactions. All right, our transactions. So that was the first change to make, and congratulations if you included that. But as I said, that's not all. We have a second change to make, second modification to make this MineBlock request work for our cryptocurrency. It is, of course, to add the transaction somewhere. Because indeed, what do we do here exactly? Well, we have our block, that's for sure, but we call the transactions key of the block dictionary. You know, the block is a dictionary of several keys, and one of them is the transactions. However, this transactions key here is so far nowhere. You know, it's not taken anywhere here, and that's of course because our previous implementation of the general blockchain didn't consider the transactions. But we actually need to get these transactions, and that's exactly the second change we have to make here in this MineBlock request. So where are we going to add them? Well, I suggest that we respect the order given here. And so let's add our transactions right after the previous hash. So now the question is, how exactly do we add these transactions? Well, good news. We made a function that does exactly what we want. That is the add transaction method. That takes as argument the sender, the receiver, and the amount of add coins the sender sends to the receiver. All right, so let's just use this function and we'll get exactly what we want. And so to use this function, we'll first need to take self, which since now we're outside of the class is our object, that is blockchain. Remember, that's exactly what we created here. Blockchain is an object of our blockchain class. So blockchain, and since add transaction is a method of our blockchain class, well, to use this add transaction method on our blockchain object, we simply need to add here dot add transaction. All right, perfect. Add transaction. And so now one final difficulty to pass, it's to know exactly what is the sender, the receiver, and the amount. So the answer to that question is exactly related to what I explained at the beginning of this tutorial, which is that when you mine a block, when a miner mines a block, he gets some add coins. We're going to give a gift to the miner whenever the miner mines a new block, and this gift will be some add coins. So the sender will be, well, the node address, which we created at the beginning of this tutorial, right here. So that's our sender. And then the receiver will be the miner. And we could say, for example, that the miner is yourself. So since this is Adelin speaking here, I am the receiver, and therefore I am going to get the add coin. So the receiver is Adelin. And how many add coins am I going to offer myself? Well, let's be generous to myself, and I'm going to give myself 1 million add coins. No, maybe that's too much. Maybe just 10 add coins or even 1 add coin, because the proof of work is quite easy. All right, and that's it. That was the second required change to make this MineBlock request work for our cryptocurrency. Now we're good. And so we have actually one final step in this part 2 to make our blockchain hold a cryptocurrency, and that is of course to make this new request, which we'll call simply add transaction, and that will add of course the existing transactions that we post in Postman through a post request in a JSON file in our blockchain. So we'll take care of that in the next tutorial, and until then, enjoy blockchains.